All right, we're in graphing calculator day 1 here. We're just learning to use the graphing calculator. And here's what they want us to do. This square right here, or this rectangular dude, is what we call the window of our graphing calculator. It's like the entire screen of your graphing calculator. And we're going to take some stuff that we pretty much know how to graph already, like if we was to do it by hand. We're just going to take baby steps and learn how to graph it on our graphing calculator. And I beg any of you watching this video, if something is going wrong, come see me, and I will fix what's wrong with your calculator. Because if you are messing around with the buttons, or if you're trying to work ahead of me, you're going to turn things on or off that are bad. So if you have some problems, come see us, and we will definitely show you what to do. So here's what they want. We're going to make a sketch of this, even though it's going to be very accurate. You'll always use a straight edge. And we got to identify. No. Don't get started. Okay? Don't get started. Just follow my lead. Okay? Just follow my lead today. We're going to identify all these different things going on this puppy. We want to identify all the intercepts, being the x-intercept, the y-intercept, any minimums or maximums, and then give some other fancy words like points of intersection and points of inflection. We won't deal with points of inflection. That's an FST thing. That's over our head. But we're going to list basically all the crazy points. And here's what really does the work for you, your brain. Your brain does more than this calculator. They are asking us to graph this. I've got a question for you. Do you know what that should look like? Yes or no? Yeah, that's a line, correct? Do you know the slope of that line? 2. So shouldn't that go up from left to right when we graph it? And do you know the y-intercept of that line? 5. It's going to be pretty plain Jane. But how to do it in a calculator. So check out your calculator right here. And we've got all these cool buttons. You see this button right here at the top that says y equals. Cool. Anytime you want to graph an equation in your graphing calculator, it's got to be solved for y. It just won't do it if y is not all by itself. This guy, y is all by itself. Please hit the y equals button. And if you're watching this video and any of these plots right here have a dark box around them, you're in bad shape. We've got to turn those off. I've already done that for everyone in class today. I've turned those off in case they were accidentally on. But things are going to be in bad shape if you see that turned on. Cool? And I can show you how to turn that off if you just come see me. But here they've got all these different y equals, y1, y2, y3, etc. Our graphing calculators can actually graph 10 different equations at one time. Some of them 8, some of them 10. It just depends on which kind of calculator you have. But we can graph 10 different things at one time. That's a little too much to get started with. We just want to graph one thing at one time. We want to graph y equals 2x plus 5. Cool? They've already got the y equals for me right here. See my cursor just blinking right here? So what we're going to do is we're going to type in what we see, 2, and here's your x button right here. It's right underneath the mode. It's this guy right here, x plus 5. Cool with that? And then the hardest part about graphing stuff is figuring out what you want what's called the window to be. Like, if you was to graph it on a normal grid, you know, it's like, what's the scale counting by on the x-axis? What's the scale counting by on the y-axis? And it's like, how high do I need to go? Question again, do you know what the y-intercept is? 5, right? So wouldn't you agree if we made a real graph of this, you'd start at 5 on the y-axis and then rise 2, run 1, rise 2, run 1? So would you agree, like, what we call the standard window? Like, if I gave you a piece of paper, doesn't the standard graph that I give you go from -10 to +10 on the x-axis and -10 to +10 on the y-axis, right? Isn't that the standard grid? Well, here's where we can figure that out. You see this zoom button right here. If you hit zoom, go ahead and hit it, it gives you all these different windows that you can graph it by. Option 6, it says Z standard, correct? That stands for the zoom standard. That's our standard window. Let's hit it. So just hit the number 6. You could either go all the way down with your cursor if you wanted to, or if you just hit the number 6, because that was option 6, it would do it for you, and it'll start to graph that thing. Cool? And what I want to show you is if you hit the window button right here, see the window button? If I get too fast for you, please slow me down also, okay? But if I hit the window button right here, it tells me all of this cool stuff. What the x minimum is, what the x maximum is. What does that mean? That's like your x-axis scale. Like if you was to make the graph, like what's the lowest number over here farthest to the left? -10. X maximum, 10. And this x scale right here is what that stands for. Like what are you counting by? Counting by 1s, right? And then they do the same thing for the y minimum and the y maximum, and this y scale, counting by ones, and then this x resolution, nobody knows what it means, but it has to be 1, okay? Nobody knows what it means. I'm sure somebody does. I don't know what it means, but I do know that it has to be 1 for this to work, and it should always stay 1 unless you are playing around with your calculator when you're not supposed to. So check this out. I've changed from my window. I want to get back to the graph, right? I want to see the graph of this thing again. If you hit this button right here that says graph, it will take you back to the graph. And our job is to make an accurate sketch of this. So the first thing you will do is realize, do I see everything I want to see? I need to see the x-intercept of this graph. I need to see the y-intercept of this graph, any minimums or maximums, or any places of intersection. Do you see the x-intercept, yes or no? Yes, it's right here. Do you see the y-intercept? Yes. Being how this is a line, it doesn't have any minimums or maximums. It goes on forever, correct? And there's no places of intersection because we only graphed one thing. It's when we graph more than one thing. So here's what we do. We realize I can see what I want to see, and now we're going to make a sketch of it. And the first thing you'll do with your straight edge is you will plot your axes. How do they relate to the screen? Just say that they're dead center. Would you agree that they're dead center? Take your straight edge and let's do that. Let's make an x-axis dead center. Do not put any arrows on it whatsoever, because all we're doing is we're just making a drawing of what we see on our calculator. No arrows on our calculator, no arrows on our paper. Cool? The axes were dead center, baby. And then we've got to put our window parameters around the outside. They're like my buddy Eminem and his 2 trailer park girls. They go around the outside. I don't know if you know about that or not. But what was our window parameters again? Well, what was the x minimum? -10. So I'm going to put that right here. This is the lowest number on the x-axis scale. And my x maximum was a +10. So I'm going to put him over here on the outside. Same thing with the y's, 10 and -10. Those are the window parameters. You put those around the outside. Cool? And then we need to totally calculate where all of these other things are. Guys, I know you know where the y-intercept is. Where's the y-intercept? It's at 5, right? But how would you figure that out if it was more complicated of a graph? Cool? Calculate is the menu we want. I want to calculate something. Do you see this trace button right here? Above it, in a different color, mine is blue, does it say calc or calculate? There's our good friend right there. To get to that second option, you hit the second button first. So you'll hit second, calculate. Cool? And it gives us all these different options. We could calculate a value. We could calculate a 0, a minimum, a maximum, an intersect, and all kinds of calculus stuff that you don't need to know about yet. But we want to find the we're trying to find the y-intercept, correct? So to find the y-intercept, that's where we want to calculate a value, right? So that's option 1, a value. And you have to have some smarts. You have to know, in the ordered pair for the y-intercept, what the x value is. What is the x value of this ordered pair? Isn't it 0 every time, right? So you just type in 0 right there, x equals 0, and hit equals or enter. Right? And it will tell you what the y value is. Doesn't it give it to you at 0, 5? Right? So you will plot that point and list the ordered pair, 0, 5. You're just going to guess. It's halfway, though, right, since that was from 0 to 10. If you get behind, let me know, and I will come help you. Okay, so we found the y-intercept, correct? Now I got to find the x-intercept. Everybody see it right there? Cool. You could do algebra to figure out the x-intercept, but we want to let the calculator do the x-intercept for us. So how do you think I will calculate the x-intercept? What menu should I go to? Second, calculate. Go into the calculate menu, and here's what I'm looking for. To find an x-intercept, we need to find what's called the 0. That's option 2. So now this is weird, right? It's given me instructions. It's like asking me questions. Do you all agree that the x-intercept is like right here where my arrow is pointing at? And you see this cursor just blinking at me, right? The calculator is asking, dude, where is somewhere left of the actual x-intercept? If I drew a vertical line right here, would you agree that over here is somewhere left of it, correct? I need to get my cursor to go to the left of it, so I'm going to move my cursor left, 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 left. Sit down. They don't do that in basketball games anymore. But here's where the x-intercept is. Now I do know that that cursor is below it somewhere also. But would you also agree if I just put a nice little vertical line right here, that is to the left of it also? So please move your cursor to the left of it somewhere is what that is saying. Please go left bound. Once you get there, hit equals. Cool? Then it says please go somewhere to the right of it. So here it is. I need to move my cursor somewhere to the right of it. Give yourself enough room where you definitely know it's to the right of it. Here's the actual x-intercept. Would you agree that cursor is to the right of it somewhere? Even though it's above it, it's to the right of it. So hit enter. And look at these two little triangles that showed up. You're telling the calculator that the x-intercept is somewhere between those two little spots down here on the x-axis. It's like you've given it a range to search through. It's like it's between here and here. They ask you to guess where it's at. You don't need to move your cursor anywhere else. All you have to do is hit equals, and it will find it for you. And where is the x-intercept at? Negative 2.50. So we will plot that point. Remember, if you want to put negative 5 here, like on your scale, just so you have a little reference, but I need to go like right here. Negative 2.50. And then put an ordered pair around it. Groovy? Then I can look back to my graph. Is there anything else I need to calculate? I've done the x-intercepts. That's the only one. I've done the y-intercepts, correct? There's no minimums or maximums, and there's no intersection points, so isn't that it, right? Take your straight edge, connect them together, and then you will use a highlighter, which I forgot to tell you to get out, to highlight the actual graph itself. Do not go through the graph, the grid or anything. Don't put any arrows on it either. You're just drawing what you see. So I can get you a highlighter here in a second. All I want you to highlight is that green thing, which is the graph. Okay, so we're going to use colors. And if you're on OneNote, I want you to use different colors also and the actual line maker. So you make your axes the same color, then your graph a different color. And then when we make parabolas stuff, you just have to freehand together, but change colors. So that's it, right? And here's what we need to do. We probably better make some notes of how the heck we found these points, because it's just a little too confusing. So somewhere at the top of the page, where you got room, let's make a little bit of notes. How did we find the y-intercept? So here's notes for y-intercepts. Cool. We did second, calculate. Awesome. For a y-intercept, we did second, calculate. And then the weird thing is it's option 1, which is called 0. Come on, get there. It's option 1, which is called value. My bad. Value. So we did second, calculate, and then it's the first option in that menu called value, and then it's asking you to type in x equals 0. Cool? So that way, because it's brand new to us, when you're doing homework, you got this written down. And then the x-intercept. Second, calculate. Option 2, which is a 0. And then you just follow the prompts from there. You don't need to write that down. The calculator prompts you what to do. If you need help with that, we could help you. Okay, so far, there is our accurate sketch of this situation. So that's just one. Let's jump. We're going to skip number 2 because it's the same concept. Isn't that a line? Again, if you graph it, same concept. Let's get to a little more complicated. If we graph this, let's use our brain first. What would this look like? What is this bad boy right here? That's a parabola, right? Because it's x squared, biggest one. Does it open up or does it open down? That opens up because its a value is positive. So let's go to our calculator and let's type them in. Go back to y equals. And then instead of trying to type over the top of that stuff, which can get you in some trouble because it gets weird, just clear it out by hitting the clear button. So your cursor's in there, just hit clear, and it'll take that entire old equation away. And you just type what you see. 2x, remember x again is right here. Squared, you could hit the squared button if you want to, like that. Or if you don't want to do that, you could raise it to the second power. Either one of those does the same thing. Minus, so here's the big deal. Minus versus subtract, right? Or excuse me, negatives versus subtracts. We want a subtract, correct? Subtract 3x, subtract 2. Cool? And I don't know what it's going to look like yet. I do know it's a parabola, but what window it'll fit on? Let's try the standard window. So that's zoom 6. All right, let's zoom 6 it. Zoom 6. And let's see if we see what we want to see. What I'm looking for is all the x-intercepts, like everywhere it crosses the x-axis. Do you see those? I need to see all the y-intercepts where it crosses the y-axis. Do you see that? And any minimums or maximums. Would you agree this does have a minimum of the graph right here? I see it all, but it's too small. It's too small. I mean, yeah, it's all there, but it's all in this little bitty spot right here. Look at the entire window of my calculator and all the wasted space that I could care less about. So even though I see what I want to see, I could use a better window. The standard window goes tens all the way around the outside. What if we shrunk it down a little bit? Instead of going by tens, what do you want to go around by? How about fives? What do you say? So how do I do that? You got to literally punch it in. I want to change the window, right? That's what this is called. Take a guess what button I got to hit to change the window. Window. Cool. So the x minimum, I don't want it to be negative 10. I want it to be negative 5. It makes a difference if you use a negative 5 or a subtract 5. Make sure you use the negative button. And the x maximum, I want that to be a positive 5. X scale, keep it counting by ones. And the x min, and then y min, negative 5 and positive 5. Changing the window. Cool? And now you can't hit zoom 6 anymore because that would put it back tens again. We've got to get to the graph by hitting the graph button. So here's the window that I want. Just hit graph. And let's see if we see all the stuff we still wanted to see. I agree that we do, right? So this is much better. Where's the axis at? Are they dead center? Yes or no? So a big mistake that you would make is to put the axes there first. Not every time will they be dead center. Sometimes that window won't make sense. In this case, they do. So let's draw our axes with a straight edge. These are dead centered. Boom. Boom. And you put your window parameters around the outside. If you don't remember what they were, hit the window button, and they will show you what they are. But they were 5s all the way around. Some of them are negative. And there's no particular order to find all this stuff, but we need to find the x-intercepts, the y-intercepts, and the either minimums or maximums. Let's start with the y-intercept, because that's the first thing we had written down. You've got it written on your paper. How to do it? Let's do it. Tell me what to hit. Second, calculate. And I want to choose a value, which is option 1. And I want to let x equal 0. Hit enter, and it will tell you where that's at. 0, negative 2. So plot that point. 0, negative 2. Yeah, let's put it in a different spot, Mr. P. Get away a little lower. Is that the only y-intercept, or are there more? That's the only one. X-intercepts now. Cool? Let's try to find this one. Would you agree there's more than one? Right? There's this guy right here, and there's this guy right here. Let's try to find this one. I need to calculate it, right? So we go to second, calculate. And which option am I using to find an x-intercept? Yes, the 0 option. Option 2, which says 0. It's weird like that. It's like option 0, or it's option 2, which is 0. And then I need to go left bound and right bound of it. So I got to move my cursor. And I need to be to the left of that guy. Here it is. I know that cursor is above it also, but it needs to be to the left of it. And that is to the left of it. Hit enter. Right bound. Move it to where that cursor is somewhere definitely to the right. Hit enter. And then guess, just hit enter one more time, right? You set your boundaries, and when they ask you to hit guess, just hit enter. And it tells you negative 0.50. So we'll plot that point. Don't put any fractions on here. We'll use decimals all the time. Cool? Find the other x-intercept. I'll do that for the video, folks. You go second calculate to that second option. Now you got to move your cursor over there, somewhere to the left of it. And if you need help, please let me know. I'll come help you. Somewhere to the right of it. And guess. Hopefully you're coming up with at 20. Sound okay? I want to show you another way you could have figured that out, because on that one, it's pretty darn obvious. With this window, it really looks like that was at 20. Like, can you kind of tell? That's totally at 20. This one, you don't know where it's at. It doesn't hit one of those scale markers nice. You might guess it's at a negative 1/2, but you really don't know that it's a negative 1/2. But that one, I'm totally pretty sure that's at 20, right? So check this out. There's shortcuts to this stuff. The trace button right here, you see that? Hit trace, and then just type the number that you think that was at. Do you agree that we thought that was at 2? So just hit 2. It's like I hit trace 2. And that does a shortcut for that value, that second calculate the value. See how it's saying x equals 2? All you have to do is hit enter, and it'll tell you, yep, that's at 20. So I just hit trace 2. Trace 2. If I hit trace 0, that's that y-intercept shortcut right there. There's that y-intercept again of 0, negative 2. So either way works. You can go through the second calculate menu, but if you just want an x value, that's what this stands for. That's what value stands for. It's like, what's the x value you want me to calculate? Like the value. So if you hit like trace 0, it's going to calculate an x value of 0. If you hit trace 1,000,000, it's going to calculate an x value of 1,000,000. Right? So you just got to do that. But is there anything else we need to figure out on this bad boy? We've got intercepts. Are there any maximums or minimums? There is a minimum right here, correct? Isn't that as low as this graph gets? How do you think we will calculate that? What menu would you want to go to calculate something? Go to calculate. And I wonder which one of those options will calculate the minimum for me. Minimum, right? Option 3. So then you got to go to the left of it. Enter. To the right of it. Just got to move your cursor somewhere left of it, somewhere right of it, and then guess. Just hit enter again. And now we get into that awesome situation where everybody's calculator is a little different. I'll bet most of your calculators don't have the exact same number that I have right there. I'll bet some of them just say plain old 0.75, right, with nothing added. Some of them might say some 0.7499999999 or something like this. Your calculator doesn't have the kind of memory to get everything perfectly right. You know, it's just like computers. Aren't some computers way better than other computers? Like, why are there computers in this world that cost $20,000? It's because they've got the kind of RAM and the kind of memory to really calculate things, right? These calculators don't. So this, it's trying to tell you, would you agree that that's just like plain old 0.75, right? And all these zeros, 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 zeros are just, we're getting close. If you have this 0.749999, blah, 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 some other numbers, isn't that getting really close to 0.75? So you've got to use some of your good estimation skills to realize that this point is exactly at 0.75, negative 3.125. So we will put that there. Don't round it. That's negative 3.125. That's exact. That's like negative 3 1/8. Nice. And notice where I put it. It's lower than that guy, right? It's just right here on my sketch. Use the calculator sketch to help you realize where that's at. It's right here. It's right here. Cool? Anything else? Intercepts? Got them. Minimums or maximums? Got them. Places of intersection? Can't do it due to the fact that I only have one graph, so it's time to now sketch this thing together. Sketch it best you can. Make it look like what your calculator looks like. No straight edges for this. It's not straight. It's a curve. No arrows, though, either. And then highlight it. And then on OneNote, you'll just have to freehand it just like you did and highlight it whatever color, or use a color different than your axes. Sweet. Next one. If I let you do this, we'll skip that one. Sorry. Next one. If I let you do that one on your own, you'd be here all day. Because you'd punch it in and try to graph it and be lost. Because you never thought about it ahead of time. First question. Do you know what shape this will make? Is it a line? Is it a parabola? Is it a cubic? Do you know what shape that'll make? Parabola. Good. Do you know which way it's going to open? Up or down? Up. Now, if I graph that on the Zoom 6 window, I won't see a darn thing. Can you figure out why it won't show up? What's in there that's making something just out of the standard parabola window? Aren't they adding 50 to it, right? So where's that going to move the parabola if you add 50 to it? Up, down, left, right? What do you think? It's going to go up 50 units. Remember back in Algebra 1 where you did that graph translation theorem where you did step 1, step 2, step 3. This gets reflected over the x-axis, translated this many units right and this many units up and down. This gets translated 50 units up, right? And which way is the parabola going to go? Up or down? So this is like the minimum of the graph right there, which we'll get better at, right? I understand it's new to you, but we totally can punch this in, just like here. Let's clear that guy out. 3x squared plus 50. But I already know that Zoom 6 isn't going to work. I'm going to do it just for your entertainment value. I'll Zoom 6 it, look at the standard window. This little thing right here moving means it's thinking, it's thinking, it's thinking, it graphed it, boom, it's done, it graphed it. You don't see it, right? Oh no, you don't see it. The window is not good for us, so we need to change it. Let's change the window. Who has to change? Out of the x minimum, x maximum, y minimum, or y maximum, who has to change if that thing's moving 50 units up? The y what? Maximum. So I definitely know my y maximum has to be, what do you think, in relation to 50? Should I just put 50? Should I put bigger than 50? What do you think? Y larger than 50, that's the correct answer, y larger. Parabola's open and up, right? So what do you want to go to? Let's go to 100, right? Just, I don't know, made it up. I know it's bigger than 50. Now, here's some other things. Slow down. If you was to really have a paper graph, and you were going to go up to 100, but these other guys are only going to like 10s, right? Would you count by ones to get up to 100? What would you count by? Probably 10s, maybe 5. So I'm going to change the x scale to be 10, man. On that y, the y scale. I said x, I'm sorry, but the y scale to be 10, because I want to count by 10s. Cool? And let's graph it and see what it looks like. Maybe we won't see it all. Maybe we will. But let's graph it. So let's see what we see here. This is the x-axis, cool? Because isn't this negative 10 way down here? This is all the way up here to 100, positive 10, negative 10. I definitely always want to see the x-axis and the y-axis on your sketch, right? And do you see how I've got this as basically as low as I can possibly get it, because I want to have a little bit below there also? I think that's a wonderful window for this. I do see the y-intercept. There actually is no x-intercepts. This guy never crosses the x-axis. Cool. And I do see the minimum of this puppy. So this is why you don't just go nuts and put your scale right, or your x-axis and y-axis right in the middle. Are the x-axis and y-axis right in the middle? This guy is, right? Isn't the y-axis dead center? But the x-axis is way down yonder here. Cool. Put your window parameters. around the outside. The x-axis is way down low, so in my sketch, he's got to be way down low. Go ahead and put those 4 numbers around the outside. If you don't know what they were, hit the window button, and they will tell you what they were. And yours doesn't have to be exactly the same as mine. Like people might ask, like, what if I only went up to 80? Then put 80. If you see what you want to see, there's no one perfect window every time. Nice? So y-intercept and the minimum. Do you think that they're the same thing? Just guess it, because you don't know. Do you think they're the same thing? I think so too. Let's try the old y-intercept first. There's the long way to do it. You could go second, calculate, choice 1, and then type in 0, right? Or if I get out of that and try again, I could just hit trace 0 if I wanted to. Like, that's the fast way to find the y-intercept. Trace 0, because as soon as you hit trace and hit any number, it says, oh, you want to calculate when x equals whatever number you just hit, right? So I'll do that, and boom, 0.50. Cool. How do I know if that's truly the minimum or not? I probably better calculate the minimum and see if they're the same thing. So to calculate the minimum, second, calculate minimum. Left bound, go left a little bit. Right bound, go right a little bit. Guess. Oh no. Oh no. Your calculator might say something 100% different than mine also. Mine's a pretty old calculator, It's been around. We got this in 07, so it's a pretty old calculator. But how many people have something different than mine? Just give me a little hand up. Probably all of you. But we all have the same thing. Because back in Algebra 1, we were taught to read this crazy language here. Do you see that letter E right there? Anybody remember what that letter E is all about? Scientific notation is what that is. This says 1.4523 times 10 to the negative 6. That means I would move the decimal 6 places to the left is what that means. So here's what this number is. 0.00000. That's 5 of them, right? 1, 2, 3, 4, 5. 1, 4, 2, 3. And what number is that really trying to tell you that is right there? That's 0, right? This is scientific notation, right? And it's trying to say, man, we tried to calculate this thing, but it was so close to 0, we just didn't have enough memory to get it actually at 0 in this particular calculation. But aren't they saying 0.50? How many years actually said 0.50? Just out of curiosity, one person, right? The others, you might have had something really, really, really different than mine, but it all means 0 in the same context. So folks, that calculator is great if you know how to read it, right? If you know how to read it. I'm telling you that for other basic purposes, the brain is way smarter than the calculator. But you got to look for the E's. So let's put it 0.50. That's the minimum and the y-intercept at the same time. Is there anything else I need to plot on this graph? X-intercepts? None. Y-intercepts? Got it. Maximum, minimum? Got it. That's it. So, Coabala. And highlight it. It helps me grade, is why I like you to highlight. It makes it much easier for me to grade. And now they want us to graph 2 different things at the same time. So pick one highlighter. I don't care which color you pick, and highlight this guy, that color that you have chosen. Groovy? And other color for that guy. Both of those are what shape when we graph them? They are lines, right? And unless they are parallel lines, they will intersect each other somewhere. Are those lines parallel to each other? They would have the same slope if they were. So they're going to intersect somewhere. We need to see that when we graph them. So let's go punch them in. We go back to y equals and clear everything out that we have. The first one that they give you, please make that y1. right? It's the first one goes with y1. So negative 1/2 fractions, dear Lord, you don't have a fraction button. Here's how you do it. You got to put it in parentheses. Parenthesis first. Negative 1 divided by 2, close the parenthesis. Fractions are just with the division sign. Then x plus 4. Make sure you don't have subtracts there. It's a negative, not a subtract. Cool. Second guy, 2x minus 6. Those of you that have a color calculator, it will graph these two things in two different colors for you. Much easier to read. If you don't have a color calculator, you kind of got to pay attention or know a little bit about the graph to see which one's which. So watch this. Mistake number 1. I'll do it. See if you can figure out what I did wrong. Those are both correct. No doubt about it. All right? Watch this. I hit the graph button. The window was from the previous problem, right, which went up to 100, right? And it's like, maybe that's not necessary for me. What do you say we try to go back to the standard window? And how do you go back to that standard window? Zoom 6, baby. Zoom 6. So same thing. There's the first line, the red one. There's the second line, the green one. Let's see if we see what we need to see. Do you see in this first line, let's just pick on him, both intercepts, x and y intercept? Second line, do you see both intercepts? Yes. Do you also see the place of intersection? This is a great window then, right? So let's make a nice little start of our sketch. Dead centered is where we were. You want to see all the intercepts and all the places of intersection. Tens all the way around. That window parameter thing is the stuff that gets forgotten the most. Like, what was the window? Cool. All right, now we got to go one line at a time. Don't try to do like don't try to find the y-intercept for the first line and the y-intercept for the second line. Do an entire line first, and then do the second line second. So on the first line, okay, which was this red one, if you want to calculate the y-intercept, go ahead. But folks, it's in slope-intercept form. What's the y-intercept? It's at 4, right? But I just needed to teach you how to calculate it when it wasn't a line or anything like that. So plot 0, 4. So whatever color that I guess we're doing it in pencil first, my bad. So 0, 4, that'd be about right now. And here's what we need to do. We need to find the x-intercept of that first line, correct? You've got instructions that you'll need to kind of get memorized of how to find the x-intercept. It's on the front side of your paper. How do you find the x-intercept again? You know it's definitely in calculate. What are we calculating, though? The zeros. Now, watch me, because something's different here. You have two different lines graphed here, right? So you've got to make sure you're telling your calculator which line you want it to calculate the x-intercept of. And check this out. Do you see up here, all of a sudden now the actual function showed up on our screen? And what does it say that it is? It's which one? y1. Now watch this. Uh-oh. I just switched to the other guy, right, by hitting up or down. Now I'm on the wrong line. You've got to make sure before you're calculating. If you want to find the x-intercept of this line right here, you got to know who it was, right, if it was y1 or y2, and you got to make sure that it says that you're on y1 right there. We all on y1? So let's calculate that. To the left of it, hit enter. To the right of it, hit enter. Remember, we're trying to go right here, not the x-intercept, excuse me, not the y-intercept, but the x-intercept. This old boy. Oh, come on. Hit enter. Then go to the right of it, hit enter, and enter again. 8-0? Yes, no, maybe? Plot it on paper. 8-0. Correct? That is enough to draw the line. Don't you have 2 points on that line? Correct? Take your straight edge and draw that line. I'm going to switch colors here and go blue. Swing and miss. Mine's a little broken, but blue, blue. Now do that for the other line. Do you know what the x-intercept, and excuse me, man, I'm so backwards today. Do you know what the y-intercept is of that second line? -6. So plot that point. And I want to find the x-intercept of that line. So 0, -6. Make sure you plot that right. Don't put -6, 0. Like write it down backwards. To find the x-intercept of this line, same concept, second calculate. And you want which option again? 0. We want the 0. And now I've got a problem because my cursor is still on y1. Right? It's like I don't want y1 anymore. I found him. To change to the other line, you use either up or down. It doesn't matter which one. Either up or down, video people. So if you hit down, it'll go down to that line. If you hit up, it'll go up to that line. But here's the problem. It like totally disappeared off the screen, right? Because let me go back down to y1. Isn't the cursor, the x value of the cursor is here at like 8 something or other? When I jump up to the other line, when the cursor's at 8, it's off the screen a little bit. It's way up here. But it's still there. Go up to that line, and now just start moving the cursor to the left. All right, so that was weird. I'm going to go through that one more time. Here's where my cursor was previously. Right? From the previous line, it was sitting right here. When I jump to the other line, the x value of the cursor is still going to be at like 8.2 something or other. But when I jump there, by hitting either up or down, that cursor is now at 8.2, 10.6. You kind of see that? That's telling me where my cursor is at. And 10.6 is off the screen up here. So you got to re-find your cursor and then bring it back down to Chinatown. Go left of that x-intercept. Hit enter, and right of it. And where is it at? At 30? My calculator's way slower than all y'all's. 30? Plot it, connect the dots. And you should have highlighted that the colors also, like when you were done. My fault. Whatever color you highlighted that line, highlight it that color when you're all done. And there's one more thing we still need to calculate. Even though we have the sketch done, there's nothing more to our sketch. There's one more thing. We've done all the intercepts. We've done all the minimums or maximums because there are none for lines. But there's one more thing, places of intersection. So how do you think we will calculate that? Second, calculate. And on there, it's option 5, which says intersect, correct? So hit option 5. And now here's what it's telling you. They say first curve. People are like, what? None of these are curves. Your calculator automatically calls anything you graph a curve. Right? It doesn't matter if it's straight or truly curved. They're calling them curves. How many curves do we have graphed total? 2, right? But remember, you can graph up to 10 of these at one time. So they've got to ask you. It's like, hey, man, which 2 things do you want to see where they intersect? So first curve, would you believe that y1 is one of them? Right? Just hit enter. Second curve, it'll automatically jump to it right away because it's the only thing left. Would you believe that y2 is the other one? You're looking up here in the left. y2 is the other one, correct? Hit enter. And then it's asking you to guess. You're going to need to move your cursor somewhere close to it if there's more than one place of intersection. Isn't there only one place of intersection, though? So you just have to hit equals on guess because it'll go find it for you. And there it is at 4,2, baby. At 4,2. So we just go to our sketch and we plot that. It's right here. 4,2. D-O-N-E, done. Nice? One more. Let's skip 7 and go to 8 and call this the last one of the day. Think before we punch, though. We're going to number 8, which is the very last one here. 2 different colors. First one, blue. Bop, bop, bop. Second one, green. Sorry. First one, when you graph it, what will it look like? Parabola. Open in which way? down, right? And it's like it's got that +8, so it's probably going to fit in the standard window, right? It's going to have a y-intercept of 8 basically right there, and it's going to open down. Line, y-intercept of -5, standard window is probably going to be good for us. So let's go to y equals and clear everybody out and start over. y1, -2x squared plus 8 down to the other dude, 3x minus 5. Zoom 6 it, right? I feel that the standard window is going to work. Let's see if it does. There's your parabola. Oh, there's my line. The question now is, do you see everything that you need to see? When it comes to that parabola by itself, I see x-intercepts, correct? I see maximum. I see y-intercept, good. When it comes to the line by itself, I see y-intercept. I see x-intercept, good. But how about places of intersection? You see this one, right? Will it happen again down here? And we don't see that. So we need to change our window. And who has to change? Out of x-min, x-max, y-max, or y-min, what has to change? The y-min. By how much? Probably not much. It looks like it would be about right here, correct? And this is -10. I'll bet if we went down to maybe -15, we'd see it. I don't know. I'm just guessing now. I don't know. So I'm going to change my window by hitting window and changing the y minimum to -15. And I'm going to let it count by ones again. Close enough, right? Let's just see if that's good enough for me. How do I get back to the graph now? Hit the graph button. And I'm looking for that other place of intersection, if I see it or not. Woo! Pretty tight, right? Pretty tight. It's right there. I probably better spread her down just a little bit more. Let's go down to -20. Window, -20. And now I'm going to change my scale. Right? Might as well count by something different. Instead of ones, what do you want to count by? Fives would be fine. I wouldn't have a problem with that. I'm going to go by twos. Right? There's nothing wrong with fives. There is no perfect window. Guys. You just got to see what you want to see. Cool? You got to see it all. So people are like, how did you know to do that? I'm playing around with it. I tried -15 and it didn't work. So I try again, right? You're just going to have to play around with it. So I'm going to graph it. Even if you kept the scales counting by ones, no big deal. All it did is you don't have as many of these little black dots here anymore. Now there's half as many because I counted by twos. Cool? So now, don't I see all that good stuff? So now you can't put your axes dead center, though, right? You can't put them dead center. Guess what you see? Y-axis right down the middle. This guy, about 2/3. Window parameters. If you don't know what your window parameters were, all you have to do is hit window, and it will tell you what your window parameters were. Cool? And I'm going to turn you loose. Find it all. Right? Find it all. Why don't you pause the video and see if you can find everything that you need to find. So I started with the parabola right here, and I found both x-intercepts here and the y-intercept / maximum. It's the same thing. Now that I have that information, that's enough to make the parabola. And I'm going to sketch it. And now I'm going to start on the line. I'm going to find out y-intercepts. I already know the y-intercept of the line is -5, so that's not halfway. It's here, approximately. X-intercept, I'll calculate it. I can calculate a 0, which is option 2. And notice I'm on the wrong graph. This is y1. I need to switch it to y2. So now I'll move over. And I need to be to the left of that thing, which is right there. And then to the right of that thing, which is about like right here. Guess 1.6 repeating, which that's exact still. 1 2/3, so 1.7, and we'll approximate that, guys. you can listen to me here now. Like, since you're rounding it, you need to put the approximate symbols in there. It's approximately 1.7. We're rounding it to the nearest 10th, 0, where that point is. Once you find it, then graph your line. And the only thing left is to find those places of intersection. I'll let the video people pause it again and try that. So if you want to find the intersection, you do the same concept. Second, calculate choice 5, which is intersect. And it's asking you, what are the two curves, dude, that you want to intersect? Where are they? First curve, y1, hit enter. Second curve, y2, hit enter. And now this guess becomes important, because isn't there more than one place of intersection? So it's going to find the place of intersection that your cursor is closest to. There's two places, right here and right here. This one will calculate the one that it's closest to. Wherever my cursor is, it's going to find that one. So I'll hit enter, and it's at a nasty place. Put approximate symbols on that bad boy. Approximately, put it back on the graph, approximately 1.9.7. Cool. Then to find that other place of intersection, you go through the whole mumbo jumbo again. Second, calculate, choice 5, intersect. First curve, hit enter. Second curve, hit enter. Guess, you got to move your cursor closer to that point. So that guess is kind of important. It doesn't have to be right on top of it. It's just got to be closer to that dude. So that's close enough, right? And hit enter. And it'll tell you it's also at a nice nasty place, about negative 3.4, negative 15.2. So negative 3.4, negative 15.2. And I put approximate symbols just like in front of the whole ordered pair. Okay? On OneNote, please use different colors for all of these things. You'll have the axes in a color, then you'll have the first graph in a color and the second graph in a different color. There is only 2 problems on your homework about this. The rest of it is all review. Like, this is the first review day for our chapter, right? So new stuff. But if you don't have a graphing calculator, I would highly suggest starting with those. Those are the last 2 problems on your assignment. And then next time, we will learn one more new trick about our calculator and have the second review day. That will be, what's today? Friday. So that will be on Tuesday, and then we test Thursday. Cool? So if you're on the video land and this isn't the year 2016, those dates are wrong.